What's up guys, this is LeetCode 509 Fibonacci number. The Fibonacci numbers, commonly denoted f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1, that is, f of 0 is equals to 0, f of 1 is equals to 1, f of n is equals to f of n minus 1 plus f of n minus 2 for n greater than 1. Given n, calculate f of n. Okay, so I think we can solve this using recursion, but using recursion won't gonna be the best solution for this problem because using recursion here, we are gonna have a kind of recursion called tree recursion, which is pretty slow because at the end, we're gonna have a tree in our stack. I can show you this by drawing, but the first solution we're gonna have will be the tree recursion using recursion, and after that we can improve the solution using just I think two variables we're gonna solve this you're gonna solve this problem for us. So let's try to write some code and see how this will gonna work. Okay, so as a recursion, we can start by checking our edge cases. So here our edge case will be when n is equals to 0, we can just return 0. And when n is equals or less than 2, we can return, it's less or equal than 2, we can return 1. And after that, we can do our recursion case, which will be the fib of n minus 1 plus fib of n minus 2. And that's the recursion here. We can try to run the code to see if it works. Yes, it works, and I can show you why this is pretty slow. Let's see here. So imagine we have here the number 5 and we want to see the Fibonacci sequence here for this number or the Fibonacci number for this input. We are gonna have to calculate the Fibonacci of n minus 1, which is 4, plus the Fibonacci number of n minus 2, which is 3. To get the Fibonacci number of 4, we have to calculate the Fibonacci number of 4 minus 1, which is 3, and the Fibonacci number of 4 minus 2, which is 2. Here, we have to calculate the Fibonacci number of 3, which is the Fibonacci number of 3 minus 1, which is 2, and the Fibonacci number of 3 minus 2, which is 1. And here, in the case of 2, 1, and 2, we are gonna get the result of our base cases. But here, again, we have to calculate the Fibonacci number of n minus 1, which is 2, and the Fibonacci number of n minus 2, which is 1. And here you can see in this paint here that there are a lot of duplicate computations because we have here 3 twice, we have 2 appearing 3 times, we have 1 twice, and this is with a small number, which is 5 here. Imagine if we have a bigger number, we will have a pretty big tree. And all these here will be in the stack, which will use memory, and also will increase the time complexity of the solution. The time complexity of this solution is exponential, is it's actually 2 to the n. This is not true, this is quadratic, and this is exponential. So the time complexity will increase it will increase exponential based on the length of the input. So if the input gets bigger, the time complexity will get exponential bigger. So this is not good. We can improve the solution here by removing the tree recursion and do this in an iterative way. We can do this by saving the current and the last computation into two variables and use them to the next computations. So here we can have a last variable which will have by now 2, and the one to the last which will have 1. Why the last here gets the number 2? Because we already calculate here the base case for the number 0, the number 1, and the number 2. And the next solution, the next result here for a number, imagine a number 3, for example. I think we have the example here. Yes, for the number 3, we will get the output 2. So right now we have to do this computation. So if n is 0, we are gonna return 2 here because we already did the previous calculations. And we put the number 1 here in the case of n is greater than 0 because we are gonna have to compute the last variable plus the one to the last variable. Okay, so first thing we have to do here is to decrement 3 of n because, as I said before, we already did this computation for n equals 3 here, here, and here. And if n gets 0 after this decrement, I just want to return the result here in the last variable. And if n is greater than 0, we can start our calculations here. While n is greater than 0, we can, okay, so we're gonna have an auxiliary variable here to save the value of last right now because we are gonna need the value of last variable to put into one to the last in the next computation. And right now I want to just calculate last plus 1 to the last. I want to swap the 1 to the last to get the previous last, which is in the auxiliary variable right now. And I also want to decrement n. And yes, that's it. Here we are doing the same thing as we did before. We are calculating the next Fibonacci number by the sum of the last and the one to the last value. So let's try to run the code. Let's try to hit submit. Yes, that's it. So this solution is pretty better, is much better than the previous one because here we have a time complexity of big O of n, where n is the length of n here. And the memory complexity here is constant because it does not matter if n gets bigger, the amount of memory that we are gonna allocate will be just the variables that we are using here. So that's it, guys. Thanks for watching.